This video will demonstrate the process of the prototype for temperature, humidity, and gas monitoring system. As soon as the transmitter was plugged in with the power supply, a serial monitor in the Arduino IDE app has been used to monitor the prototype's function. In this clip, the transmitter is currently calibrating. The calibration made for the transmitter is to identify and record the data when it is exposed in the clean air. Since the prototype has Wi-Fi module via Wemos D1 Mini, it needs a Wi-Fi connection for it to work. The date, time, and the components needed, which are the temperature, humidity, and gas level, are shown as soon as it has established connection. The transmitter will update the data and record if the temperature, humidity, or the gas level had changed. This clip shows the transmitter running and its updates when the data had changed. The transmitter's gas sensor was also tested to ensure that the data for the gas level is updating and the gas sensor is working. It is tested by exposing the sensor in ethyl alcohol gas. As soon as the green light turned on, it identifies and records the gas level of the carbon monoxide in the air. This gas level determines the level of the carbon monoxide in particles per million. The channel update can be delayed due to the environmental conditions on where the transmitter is used. It is also due to the functionality and the data that can be recorded by the gas sensor. A huge number can be seen on the output, but this output is normal for the gas level because it is recorded in particles per million. The next part is the receiver of the monitoring system. It includes a Wi-Fi module and an SD card module that will store the transmitted data via SD or memory card. Once the receiver is plugged in the power supply, the receiver will be calibrated and will make a text file inside the SD card with the file name reading.txt. The data that can be seen on the receiver is similar to the transmitted data given by the transmitter. The only difference is that the recorded data on the SD card have units. Celsius was used for the temperature, gram per cubic meter was used for humidity, and parts per million was used for carbon monoxide level. Here is the actual running prototype of the whole monitoring system. The database called ThinkSpeak was used for this prototype because it is one of the free and accurate databases that can be used to monitor the temperature, humidity, and gas level. As you can see, the data that was recorded in the SD card module can also be seen on the database. The delay can be fixed by using another type of sensor, especially on monitoring the carbon monoxide level of the air. Here are the sample outputs recorded inside the SD card. We are Group 6, and this is the end of our demonstration. Thank you for watching.